Okay, so yesterday we found the mean and standard deviation for this swimming problem. So now, part B. The team's best time so far this season was, I'm just going to do it in the seconds, 199.48 seconds. Okay, but their mean time is 200.57. Okay, just keep that in mind. Do you think this team is likely to swim faster than this at a conference championship?
What do we do?
You do the problem.
That was a legit
I say
question.
no.
We're going to find the Z-score.
You can't just say no.
I
Josh.
can because I think it's no.
So we're going to use this number minus the mean. It's been a hot minute since we've done these.
I know, right?
Divided by the standard deviation.
Oh, and then whatever the z-score, we gotta go to the table.
And that'll give us the probability of it.
Oh, yeah. That's what it says. Okay.
Negative 2.37.
I trust that.
What do you
Josh
say?
had a lack of confidence.
What do you
It's on the board.
All right.
That's very aggressive. You do tell me aggression now. This is a peaceful space.
Do you know who you're talking to? This is
Josh Senior.
precisely.
Okay, so now I'm looking for the probability for Z being less than that value. Okay, because it's not a good normal model. Because our mean is here. The value we're trying to find is here. And we're looking for this value over here.
Right.
So now you're going to go to your table, the negative one. That has a picture that looks like that on it. Man, look at that. Isn't that crazy?
We have to say we think each other.
All right, so the right-hand side is your whole number and your first decimal place. So what was it? Negative 2.3. Better look before Josh tells me to look at the board. Negative 2.3.
Real.
And then I'm going to go over to the left to where it's 0.07. So this one. So this 0.0089.
Mm-hmm.
Are we tracking
Yeah.
before I keep going? Okay. So that's going to be your probability of that. So 0.0089. And since it has all four decimal places, we'll put them all. If you were doing it like off of a calculator or something, you don't necessarily have to go out that far, but
Is that a equal sign or an
it's like a little like a approximate. We're not in a congruency class.
Oh, I always thought that was congruency. To be honest.
It's in this context, it means approximately.
I always thought it was just approximate.
It is.
What's congruency mean?
See, you really
Equivalent.
is oblivious.
Yeah, equivalent. I get equals.
So no, it's unlikely.
Ha! I was right.
The probability.
Didn't say you were wrong. You just you can't just put no.
Yeah, don't just put no.
Trust me, bro.
The probability they will be faster is less than 1%.
Oh my goodness, I'm so sorry. I'm trying to tell him to put on his desk. And just realized I just gave over your water bottle.
Good job, Nathan. I don't know what all that was, but if you're just making weird noises, I could join you.
No.
I'm really good at
Nobody
it.
wants you to make weird
We're
noises,
gonna
Josh.
kill that before we produce.
Absolutely.
I told Kenny that y'all say that now, and he was like, I hope you gave me credit.
Oh.
He started that?
Yes. He says it all the time. All right. Mr. Stames likes sugar in his hot tea. From experience, he needs between 8.5 and 9 grams of sugar in a cup of tea for the drink to taste right. While making his tea one morning, Mr. Stames adds 4 randomly selected packets of sugar. Suppose the amount of sugar in these packets follows a normal distribution with a mean of 2.17 grams and a standard deviation of 0.08 grams. What is the probability that Mr. Stames' tea tastes right?
What is right is relative. Cause like
Relative to his preferences.
Right for him.
This is gonna help us. This one right here is gonna help us solve the whole problem. Okay. So I think you need to find the z-score.
I will. Eventually.
What's the first step?
literally.
We're going to find the mean for the 4 packets.
Okay.
So each packet is a mean of 2.17 grams, so times 4, because that's what he's putting in there, is equal to what?
You know, it's just
8.68.
Okay. Standard deviation. Square root of 4 times 0.08 squared. Why did I have to do it that way?
where did the 0.08 come from?
You had to with the thing because you had to make it. Wait.
Can I multiply standard deviations?
You
No.
cannot, but you can
Wait.
add variance.
I can do it with variance, so I have to convert it to variance and then back to standard deviation, and this is 0.16. Alright, so visually, the mean is 8.68. He says that he wants between 8.5 and 9.0. So he wants this area in here for it to be right. So I'm going to have to do 2 z-scores. So z is equal to 9, because that's the amount he's looking for, minus 8.68 divided by 0.16.
Wait, so what's the formula for z-scores again? So,
It's x minus mu over standard deviation.
What language is that?
Like 2 or something.
That's 3.
Whatever. It's still
Yeah.
French.
Yeah.
that's 3.
What's 1? Is it?
In German?
We're talking about French.
Alright, the other z-score is going to be 8.5 minus 8.68 divided by 0.16.
Chop chop calculator boy.
Rude. Stop. Negative 1.125.
Also, I never figured out what that one thing was from. The movie.
Yeah.
Does it still keep you up at night?
No, I don't think about it that often.
Oh,
I just thought about it because of the way that he said this one, but
I remember it from Wonka.
I'm gonna be honest.
Where
I,
else?
it could be from Wonka because I had just seen Wonka when we did that. All right, so now I'm looking at the probability. Negative 1.13. Well, yeah, because I need to round it because my z-scores go out to 2 decimal places. Less than z, less than 2. So I'm going to add those two values together. So I'm going to go to my z table, and I'm going to find the one that is negative 1.13. So just tell me what that value was, and then I'm going to add it with somebody else can find the z for 2.00,
What?
which is on the other table.
okay.
So go to your z table, and you're finding negative 1.13, and then you'll also have to go to the other table that has the positive ones and find 2.00.
Point 1292
And that's for the
Plus.
negative.
point 9772.
All right, now because this is like, I'm not going to say because it's the negative one, but if I add those two things together, I have more than 100%, right? So I've got to subtract off this one, okay? Because anything, like, I need greater than that value, so I need to subtract that amount off, if that makes sense. So I'm going to subtract that off and add this, so take this one minus this one, and what do you get? So according to that, there is an 85% chance his tea tastes right.
Such a random.
Now, do you want to know how to do this on your calculator?
Yes.
All right, so you're going to type in or go to normal CDF. Your lower bound is going to be 8.5. Upper, it's a second bars,
Oh.
is 9. Mean is 8.68. Standard deviation is 0.16.
Oh my gosh.
Whoa,
Oh,
I got
sorry.
85%.
Isn't that crazy?
Isn't
I
that
love
crazy?
that. I love my
Isn't it
calculator.
crazy that we did wrong? Pretty crazy.
It's pretty wild.
I did. What's your problem? What's your deal?
Oh. All right, the next one. I'm just going to do this one on the calculator for sake of time. Leona and Fred are friendly competitors in high school. Both are about to take the ACT college entrance exam. They agree that if one of them scores 5 or more points better than the other, the loser will buy the winner a pizza. Suppose that in fact Fred and Leona have equal ability so that each score varies normally with mean 24, standard deviation of 2. The variation is due to luck and guessing and the accident of specific questions being familiar to the student. The two scores are independent. What is the probability that the scores differ by 5 or more points in either direction? So, either direction means that they can be what? Yes, negative or positive. So, my little chart. Oh, okay. So, the mean. So, if they both score 24, the mean is going to be 24 minus 24, which is 0. No, not that we need it for this specific thing because we're going to do it with the calculator. Or, well, actually, we do need it with the calculator. But anyways, then we have standard deviation is the square root of, it's going to be 2 squared plus 2 squared because they can each have a standard deviation of 2, which is the square root of 8. Somebody can tell me what that is.
2.8.
2.82. Okay.
No,
Or-
Oh wait, yeah.
Or
I didn't know if
8.3.
we were going to. It would be 2.83.
Okay. So then I'm looking for this over here where it's -5. Why did it just draw an arrow? -5 or +5. So, if I was going to do a z-score, I would only have to do it once because one is +5 and one is -5. So the answers that I got, I would just do it for positive and negative. But I'm going to do it on the calculator. We're going to actually do 2 different normal CDFs on the calculator. We're going to have the normal CDF of, let's do the negative one first, the -1 E99 to the upper of -5. Mean of 0, standard deviation 2.83. And we're going to get that number. Then we're going to have normal CDF of 5 to 1 E99, 0, 2.83.
I got the bottom one.
They're both the same.
Okay.
What is it?
039.
Now what? Add them together. Huh?
Just stop it.
He just found out that they were the same. Both of them
Oh.
were the same number.
I was like, we're adding a number together. How can they be the same?
Wait, 07.
So, that means that about 7.8% of the time, their scores will differ by 5 or more points. last page? Alright.
No.
Oh, we might not do 11. I don't normally do number 11,
Okay. Probably.
so we might just leave that one. Alright. Number 10. Whoa. Really big, really fast. Okay. At a certain coffee shop, all the customers buy a cup of coffee. Some also buy a donut. The shop owner believes that the number of cups he sells each day is normally distributed with a mean of 320 cups and a standard deviation of 20 cups. He also believes that the number of donuts he sells each day is independent of the coffee sales and is normally distributed with a mean of 150 donuts and a standard deviation of 12. The shop is open every day but Sunday. Assuming day-to-day sales are independent, what is the probability he'll sell over 2,000 cups of coffee in a week? So I'm going to come over here and draw a little mean and standard deviation for this stuff just so I can see a little better what's happening. So I'm going to do coffee, donuts. I'm going to do X bar for mean, sigma for standard deviation. So it's 320 cups a day with a standard deviation of 20. Donuts, got 150, standard deviation of 12. And again, this is per day. Now, he's open for 6 days, right? So, what might I need to do to find the mean for the week? Multiply by 6. So that's going to be 320 times 6.
Which is, 1920.
Standard deviation.
It would be square root of 6 times.
6 times 20 squared. In case we take the standard deviation, square it, multiply by 6, and then take the square root of all that. Huh?
You didn't take the square root. 48.
I was like, wait a minute.
Oh, you know, like, well, it's not 48. Well, how far do you want it? There's a lot of 9s in here.
Yeah.
48.989, but then you gotta make.
We'll just
Oh.
But then next would be a 7.
Yeah. So just.
we can just
48.99.
Yeah.
Just go
wait.
49.
we'll just call it 49
Small 49.
just
There's
to
a
make
lot
it
of 9s.
easier.
Sounds good to me.
One of them was just missing just a little bit.
All right, so if we wanted to find the z-score for this, it would be 2,000 minus 1920 over 49. And then we can use that to find our thing if we wanted to do that way. Now, let me show you something of doing it this way. Visually, I've got the mean here, but I'm trying to get to 2,000. Right? So I need this area over here. Now, what does that picture indicate to you on the top left of that appendix page? That's the positive ones.
It's including everything to the left.
To the left. So if I actually wanted to find on the right, what am I going to have to do? Yep. So because this table is for the left and I need the right, I'm going to need to do 1 minus. Okay, so if I was doing the probability of z being greater than 1.63, then whatever this value is, I have to do 1 minus that. So what is it for 1.63?
9,9,4,8,4.
Okay, so we'll do 1 minus that, and what does that give us? So we'll just say 0.05. So basically there's a 5% chance that he sells over 2,000 cups of coffee in a week. Now, if you wanted to do normal CDF for this one, it would be normal CDF of 2,000, 1E99, 1920, and 49. And then that will actually, because of the way you put this in, this will actually give you 0.05 with some decimals after it. But if he makes a profit of 50 cents on each cup of coffee and 40 cents on each donut, can he reasonably expect to have a day's profit over $300? So I'm going to set up a table like this again, but for basically profit. So for coffee and donuts, and I mean standard deviation again. So he's 320 cups of coffee, and he's making 50 cents on each one. We'd multiply it by that, and so $160, right? Donuts, 0.4 times 150. So this is what you say, 60. All right, now standard deviation. Something's wrong. What is my standard deviation going to be? Or how am I going to find that?
You have to take square root
I would hope that you could just multiply it by the amount of money.
Yeah, that's what I have on my paper, which, yeah. Pretty sure we just have to multiply it. Because we can multiply, we just can't add. So that's the problem. So 0.5 times 20 would be $10. 0.4 times 12 is
4.8.
Oh, I was wrong.
$4.
so $4.80.
I was guessing.
Josh is 0.4, not
So now expected value, we're adding the means together. So 160 plus 60 is 220. Standard deviation. Now, because we want to add them together, what am I going to have to do?
Bar.
So square root of 10 squared plus 4.8 squared.
Is that 4 minus 8? Or 4 times? Or 4.8?
4.8.
Which is 11 point.
Actually, do this for me this time.
Yeah.
Okay.
11 point what?
09.
So now I can do z-score. So 300 minus 220 over 11.09.
Seven
7.2 what?
point 1.
All right, now look at your chart again for the positive ones.
I don't think we're gonna find that.
Okay, so what does the note at the bottom say?
Is
The
Z greater than or
the
equal to
areas
3?
are
Or 1.
to 4 decimal places.
That just means 1.0000 or whatever.
Yeah.
Okay. Now, this still showed the left side, but what do I need for this one?
The right
Alright,
side. So 1 minus 1.
So it's going to end up being, so the probability of z being greater than 7.2 is 1 minus 1, which is 0.
Oh.
So he has
So
a
it
zero.
is
It's 0.
very unlikely
So, who's gonna tell him?
We can tell him.
to make a profit. Over $300. Now, if we had done normal CDF and put this in instead, it's a chance we would see out at like the 6th or 7th decimal place that there's something and it's not actually 0. However,
It's never like 0%.
right. Well, and I mean, odds are there's a minimal chance, but it's probably like 1 in a million. Like it's
Yeah.
it's probably some really crazy number chance that he would ever do that, and it's like not inclined to happen.
That's sad. Poor dude.
All right, the probability that on any given day he'll sell a donut to more than half of his customers. So we're running out of time here, but so a donut to greater than 0.5 of coffee. So donut minus 0.5 of coffee is greater than 0. So that means that the mean for this is going to have to be 150, because that's how many donuts he sells on average, minus half of the coffee, which is 320, right? Is that the number? Okay. So minus half of 320. So that's, what is it, 150 minus 160?
Yep.
Oh dear, which is negative 10. So then standard deviation, I'm going to have to do the square root of 12 squared. Remember, we can't subtract, we have to add. So plus 0.5 times 20, and that number squared is what?
244. Wait, let me square root it. Don't do anything. 15.62.
Every time.
15.62. So then, hold on, we might just do normal CDF for time. Let me make sure it works for this one. just because it's, weird. Okay, so with this one, when we put this into normal CDF, to explain something here. So basically, more than half, so that means that they have to break even. So the mean is -10, but breaking even is 0. Okay, so when you look at this, we have -10 here, but 0 is where he wants to be, breaking even or better. Okay, so when we put this in, it's going to be 0 to 1E99, and then the mean -10, and then 15.62, which I just put it in because I was trying to make sure it was working, but 0.26. So basically there's a 26% chance of that. Yes?
Are you able to pick up?
Yes, 1 second.